too tricky to deal with. Likewise for race. But you're going to find situations where those values might be coded by 1, 2, or 3, and we'll kind of look at some of those examples. So the first example we're going to look at comes from the CINECA data sets. And these are a set of synthetic data sets that 4 data sets that CINECA put together. And I'm going to jump out, I hope, of slideshow. How do we do that? Okay.
Just tap the escape. I think should get your.
Yeah, I think we're out now. Okay.
Yeah.
And go over. I'm going to close some of these participants and. Is there any way of making the zoom thing at the top disappear because it's taking
The
up
bar?
some? Yeah.
You can drag it to a different location on the screen, like the side or the bottom. Or
There we go. That
Yeah.
helps. Thank you. Never done that before. Okay. Just getting some of the stuff off the screen. Okay, so these are the CINECA data sets, and there are 4 of them. One, the CINECA synthetic cohort, Europe, UK 1. We're going to actually, and then we've actually got this one preloaded, but we're actually going to walk through loading this, the CINECA cohort Africa H3O BioNet data. So what you would do is click on the link to go, and I'm not going to go through all these steps. The data set can be found here. It will take you to Zenodo. If you went there and downloaded that, and we're literally, sorry that this seems to be laborious. It's intentionally laborious because we're not trying to do the smoke and mirrors here. We're trying to show what actually happens when you walk in the door with that data set and you want to put it in Data Connect. And so this is what you would get when you download this set of files. And you've got to see we've got some genotypic data here and we've got some phenotypic data. And it's really the phenotypic data that we're interested in. And it's a CSV. It's actually an Excel rather than CSV. We can save it as CSV. And we open it in Excel, and what have we got? My computer is being a little slower than usual. Okay. So, in fact, we do have columns and we have data in them. And in fact, if you look at the column names, they're actually very informative about what they are. They're not suitable as column names for a database, and so that's something we will have to deal with. And I've kind of dealt with that ahead of time. But I wanted to show you what you actually start with, what you actually get when you download it. Or if you were the CINECA provider, what you are starting with if you were making your data available through this route. The other thing that we'll get is a data dictionary, which they provided. And the CINECA project defined a minimal metadata model, and here is the CINECA, the H3 Africa, the data set that we're looking at, mapping to that. And so this is in Excel. It's in some form machine readable, but this is what we mean by somebody coming to Data Connect with what they have. This is what you're coming to Data Connect with if you have that data set. So this is all good stuff because we can see that we've got documentation like the columns, what is your native language, and there are actually in here somewhere, yes, the lists of values for each of those fields. So that's what we're starting with. Now, with this, and this was probably about 30 or 45 minutes of work, so I'm not going to do it here. Took that and transformed that Excel sheet into a CSV, and took that data dictionary and also turned it into a CSV. And let's work with the data set first, because what we're going to do is go into BigQuery. Now, I should probably have stuck on the slide that Jonathan had that referenced the data sources. Fiz's example in the recording used Postgres as the data source. Here we're going to use BigQuery. We're not going to go into the details of how you set up Data Connect to access BigQuery, but it's fairly simple. It's based on the Trino tool that the reference implementation is built on top of. And you can see previously, I think, yeah, here it is where I've previously worked with these data. But I'm going to do this afresh, and I'm going to create in BigQuery a new data set, and create data set, and let's call this one Connect 22, and we better remember that name because we're going to need it later. And we're going to create that data set, and it should appear in BigQuery over here, and now we're going to add table to it. And we're going to upload, and we're going to find a CSV file that we, this is my modified version of that data that I spent the 30 to 45 minutes preparing. That's the CSV file. We're going to open that. We're going to tell it that it's a CSV. And we're going to give it a table name. And again, I need to be paying attention here. I'm just going to call it, for simplicity, H3A Bionet. And we're going to auto-detect the schema. I don't think I need to set any other settings. And then, you know, this isn't Data Connect, this is just BigQuery. That's running that. It's running a job to create the table. The table has been created, and here is our table now. And we can see, okay, we can see we have a problem. So I'm not going to try and debug the problem. I'm going to go back to what we should have ended up with was this table, which detected the schema with the column names, and it picked up that certain columns were strings and floats and so on, and then we can actually look at the data. Now, so that's in BigQuery, but our Data Connect implementation, and let's talk about that for a moment. I'm going to move this pesky zoom bar out of the way again. What do we have up and running for data? This is what you would have up and running at the end of Fiz's demo, which is Trino, which is providing access to BigQuery and Postgres and other databases. And you're going to have, this is a version of the Data Connect reference implementation called Dev Data Connect. And that is accessing a Postgres database, which it uses for housekeeping purposes. That just needs to be there. That's just where the reference implementation keeps some of its data. But the two important things here are Dev Data Connect and Trino. And so if we go back here, we can go to our I think it's, which table is that? All right, we'll go to this notebook, which is going to access the CINECA data sets. And the table that I just loaded, because we came in through door 2. This notebook connects to, and I'm just going to comment that out because it's not necessary and it'll take a little bit of time. This connects to the local Trino instance that I was running, and scroll down here. Here is the table that we added, and I am querying the one that I ran before, and this list table info, that there is actually, we can't see it here, but this is a REST API. The endpoint to get this schema is the table name /info. That's wrapped up inside a client, which is useful for convenience purposes. But I can, well, actually, I'm going to demonstrate something back here, because I want to show the other file that we created, if you remember, was that JSON schema file. And I'm just going to put it, window. I just want to remove something first. All right, what I was normally going to do was show the table where it just lists the default schema, the BigQuery that we just saw created for it. But what, with the reference implementation of Data Connect, we do is we have a local file, a local directory here, where we put that schema that we created earlier. So, and the naming convention for it is quite straightforward. We should find here, there it is, BigQuery, CINECA, CINAfrica, H3 Bionet, datatic.json. When that is what is being called when I make that API call, this API call down here to get that schema. So the point of illustrating that was, I started from my Excel dictionary that H3 Bionet had already created a machine-readable version of that, which is this JSON schema. So now we have a description of that table, and now here we can run a query against that. So this is going to the Data Connect schema, and this SQL query just gives the groupings of counts by sex from that table. But we could write our SQL query from anything that we've discovered from that data dictionary. So I go back to here, we're going to have a look at a second example.